Hello, good evening. My name is Jessica. We're talking about our presentation for the model training, the evaluation, then the model selection, machine learning operation, the limitations, conclusions, and features. First of all, our project is contrastive physiochemical self-supervised learning and knowledge distillation for wine quality prediction. Of course, the keywords we have here, we have the random forest, the support vector machine, graduate boosting, k nearest neighbors, decision tree, feature selection, wine quality, and knowledge distillation. Among the contents of the presentation, we have the introduction, the related work, problem statement, research questions and objectives, research contributions, the methodology, the dataset description, the results, conclusions, anticipated limitations and counteraction plan, the references, and then the acknowledgement. First, we have the background and introduction. According to our project, which is the wine quality, under this project, the quality of wine is a very important part for the consumers as well as the manufacturing industry. Then nowadays, all over the world, wine is like a regular beverage whereby most people use it, and the industries are using the certification of product to increase their value in the market. Unlike previously, the testing of product quality would be done at the end of the process, but this would be time taking, and in other words, it required a lot of resources as the need for human experts, like for the assessment of product quality, which would be more expensive. Basically, the research aims what wine features are important to get a promising result by implementing the machine learning algorithms, and the algorithms we have the decision tree, the random forest, support vector machine, and others. And basically, we shall use the red wine data set, which contains 1599 instances, 11 input features that will basically be based on the physical chemical tests, the output variables based on sensory data. Then here we have the related works. According to the related works, we have some references where people have worked on the same project and they have finally made it. Here you can see we have it, whereby he worked on a project that was 2020 and he used the prediction of red wine quality through the various attributes such as the random forest, the support vector. Then he calculated the performance measurements such as through got the measurements according to the qualities like the precision, the recall, the F1 score, the accuracy, specificity, misclassification error, and others. Then the other is Gupta. Gupta also worked on the same project, but that was 2018, as you can see, and he also used some important features from Redwine datasets through the various machine learning algorithms. Then under recent trends can see that recent studies have increasingly focused on the leveraging machine learning techniques to improve the prediction of wine quality. A notable study, let me say, employed a variety of machine learning methods that included the linear regression, the support vector machine, the neural networks to identify important features for predicting wine quality. And as you can see, their findings indicated that not all features contribute equally to the prediction task, rather emphasizing the importance of feature selection in developing effective models. Under the literature review, you can see that several machine learning methods, such as the decision trees, the support vector, the neural networks, have been used in earlier research to predict the quality of wine. This under the decision trees, whereby it was used by some researchers to classify wine quality with a modest level of accuracy. Nevertheless, a lot of these methods are neither generalizable. Yes. Then we have the problem statements. As you can see, we have the domain application problem and the computation. Under the domain, you can see that focus on the traditional approach to wine quality assessment based on expert testing panels, whereby they used to hire the experts to test, whereby those days could be expensive, time consuming, and the rest, unlike today, whereby and we have the computational problem. This one, the main challenge here is to develop an accurate machine learning model that can predict wine quality based on physical chemical attributes that will require appropriate features. Then we have the research questions and objectives. Under the research questions, we have the first one, we have what wine features are important to get a promising result. Then the second one, we have which is the best model for predicting wine quality, as you're going to see. And the third one, what are the best metrics for evaluating model performance? Under this, we have objectives of our wine quality project. Here, the first one is to identify and analyze the key wine features and see which one is more important to give promising results. Then the second one, to train and compare predictive models. Then we see like which model, the best model. Then the third one is to establish and apply performance evaluation matrix. There we can see the best metrics from there. Then the fourth one, to optimize the classification models through hyperparameter training. Thank you. Let me call my colleague. Yes, good evening, everyone. My name is Rose Miracles. Let me take you through from where my friend Jessica ended. She ended on the research questions and the objectives of our research. Then from there, we also have the contribution of the research. And the first one is establishment of optimal evaluation metrics for wine quality prediction. Like this research establishes and justifies the selection of appropriate evaluation metrics, like we have the F1 score, the accuracy, let me say the precision, then for assessing the performance of wine quality prediction models. Then this will also provide a standardized framework for future research and ensure reliable evaluation of models like effectively. Then another contribution there is enhanced model performance through this hyperparameter optimization. Like this study also demonstrates the effectiveness of those hyperparameter tunings in like significantly like improving the predictive accuracy of classification models for the wine quality. Then like these optimized models also serve as a benchmark and provide insights, let me say, into the importance of fine-tuning model parameters for optimal performance. Then the next one is identification
of key wine, identification of key wine features for quality prediction. Like this research also provides a clear and prioritized list of, let me say, most influential wine features like acidity, alcohol level, like that significantly, let me say, impact wine quality. Like this knowledge helps researchers and wine producers to focus on those most relevant factors that affect wine quality. Then another one is cooperative analysis of predictive models for wine quality. Like this study also offers a comprehensive comparison of these various machine learning models, like the one we are going to see in our methodology, in their abilities to predict the wine quality. So the results will highlight the strength and weakness of each model, identifying which one is the most appropriate for this specific task. So to begin with that, let me take you through the data set we are using. And for this specific project, we are still using the red wine data set that is sourced from the UCI machine learning repository. And this data set, as you see here, it consists of the 11 physiochemical properties of wine, that is including fixed acidity, volatile, the alcohol content, and so on. And the data points here are 1,000, like 1,599 instances. As we can see here, our data set has those instances, and these are our properties. So having known the data set we are working on, go on to the methodology we are going to use. So here, our methodology for predicting this one involves this systematic approach that integrates, there is data processing, that is handling data imbalances, the outliers, and so on. Then we also have the contrastive learning, then also the knowledge distribution. And after that, we shall also do model evaluation to see which one is the best. Then shall go on and deploy our model. So to begin with that, let me take you through our methodology. So continuing with our methodology involves two methods. As you can see, we have the contrastive method, then the knowledge distillation. So the first thing here is we process our data, load our data, and normalize all the features to make sure they are fit in the standard scalar. So talking about the contrastive part, here we mainly trained two models, and these models, they learn from the pairs of samples that are either similar or dissimilar. Like they are meant to do that by predicting the contrastive loss between distance of those data. Then when you come to the knowledge distillation, here we trained three teacher models, and that was deep neural network, okay, like these are our teacher models this side. We have the deep neural network, the gradient boosting, then the random forest. And under the deep neural network, we also trained the student model that learns from it, and that was the shallow neural network. Then under gradient boosting, here I trained logistic regression. Then we also have the support vector machine. And under random forest, we will have the decision tree. Then also from this knowledge distillation, we also trained a model directly, that is random forest student, we trained it directly. So after training all these models, we have to evaluate their performance. And what did we use to evaluate the performance here? We used their weighted F1 score and accuracy to evaluate the different performance within those models. As we can see here on the accuracy, so this is our accuracy score. across all models. And see all the models, our 10 models here, the Siamese with logistic regression, the convolutional neural network with logistic regression, all this is their accuracy score, and this is our model. So based on this evaluation, we see that the gradient boosting came out as the best. Then also when we come and look at this evaluation using the weighted score, the gradient boosting still emerged as the best. And also we have here, so this is the coefficient matrix for our best model, which is the gradient boosting. You can see the true level, then the predicted level. So our first true level here was 42 and 104. Then at last, the predicted level shifted from 137 up to 7. So the next thing on this, then talking about conclusions and the limitations, I'll first begin with the limitations. Like we had limited or imbalanced data set whereby we find that other features are missing, the description isn't massive, and we had to do that. Then also the high computational cost, like this can be addressed through optimizing the selection with domain expertise. Then teacher model dependence, like we can address this through like by hybrid approaches through blending of the teacher and standalone training that might retrain more. Then like the training time also trades off. Then coming to the deployment, like we also need to improve like we want to automate our deployment process so updates are faster and easier. Because here, when we're deploying this, we used Streamlit, which for us to maybe make changes, we have to make changes through Git, but we need those deployment models, like let me say Docker, which are more stable and consistent. And bringing it to our feature step, like in the feature to improve the accuracy of the classifier, it is clear that the algorithm or the data must be adjusted. Then we also recommend feature engineering, like using potential relationships between wine quality or applying these boosting algorithms on more accurate methods. Then in addition to that, we also want to apply the other performance measurements other than machine learning algorithms so that we can be able to compare the results. Then like this study, we also hope that it helps these industries predict the quality of the different types of wine, like based on certain features, and also it will help them to make good products. Then we also want to automate like our deployment processes so that we get something that is so updated and faster and also easier to use other than using the Streamlit we have used, which need like to update through it, but with other methods like Docker, like when you can like deploy and update the cloud direct. So here, based on our work, we also have the references where we're getting the research from. Then you also have the acknowledgements, and mostly to our dear lecturer, then my colleague Jessica. Thank you.